So this is a paper of KVPY, and this examination was conducted on 5th of November, and this paper is for stream SB part. So SB part means for class 12th. So we'll see the chemistry part of the solution. The major product formed in the following reaction is, so this is our reactant, and you can see this is the concentrated HNO3 and H2SO4. Now with these two reactions, what happens, the H2SO4 will act as an acid and this will act as a base. So one ion is produced, that is called as NO2 plus ion. So this is your nitrosonium ion. Now this NaCO is your orthopara-directing. Why? Because this nitrogen has a lone pair, so this will acting as a electron donating groups. So with these groups, what will happen? This is plus R effect and ortho and para substitution will take place. So NO is your it is just an electrophile, so it will attack on this one benzene at para position. So you will get if you seek answers. So this answer is only possible. This is not. This is the meta will be less, but ortho will be your major quantities than meta and ortho para-directing. So answer is our A is correct answer for these questions. Among the following alpha amino acids, threonine, tyrosine, methionine, arginine, and tryptophan, which contains the aromatic groups in their side chain? Side chain, they're asking which have aromatic groups. So this is, you have to remember the structures. So in this case, there are two structures. One is tryptophan. So tryptophan, what is actually structures? If you draw, it is going like this one. This is a ring structures, and again it's attached with the pentagonal ring is there. Okay, with a double bond. And this part is again attached with the two group. One is NH2 group and second carboxylic group. This is one ring. This is for tryptophan. We can say this is for tryptophan, and one is tyrosine. So in case of tyrosine, we having one more ring is there. So this is your ring structure tyrosine. Here is OH, and this attached with the CH2 group, and then again with the help of NH2, and this is COH. So only two amino acids which have benzene aromatic groups in their side chain. So remaining is not there. So answer is B correct. The number of stereoisomers possible for the following compound is. So if you see carefully, this is a double bond. So this is one stereocenter, and this carbon again one stereocenter. So there are two stereocenters. So N is equal to 2. So we'll use the power 2 to the power 2. Total stereocenter will be 4. So answer D is correct. In the electrophilic aromatic substitution reactions of chlorobenzene, so this is our chlorobenzene, and what is the orthopara-directing group is there? So which have 3 lone pair is present over here in this ring. So if you take chlorine is your electronegative metal, so its electronegativity is very high, so it will cause a minus, you can say here minus R effect, but it has a lone pair. So due to lone pairs, the ring is activated at ortho and para positions. So question is which is causing orthopara-directing groups? So why? Because of this lone pair, there will be the plus R effect, or less minus I effect of this chlorine. So this is your if you see the overall effect is only this is plus R effect. So orthopara is due to only plus R effect of chlorine, that is lone pair present on it. So this is our answer. Among the following, which is anti-aromatic? So for anti-aromatic, you should have 4 n-pi electrons, and plus it should be your sp2 hybridization. This is the compulsory thing, and cyclic ring, once it is cyclic ring is there. Now if you see the first one, so this is your aromatic compound. Okay, it has how many? 10 pi electrons are there. So 10 pi means electrons means this aromatic. Now this is your sp3 hybridization. It's not a plus. This is also rejected. Now in case of 3, so this oxygen will go this side. This will attain a positive charge. Positive charge, so this becomes your this is compound having 4 pi electrons. So 4 pi electrons means n equal to 1. So this is your anti-aromatic. 3 is anti-aromatic. Now in case of 4 has one lone pair this side. So 3 plus 2, it has 10 pi electrons are there. So this is your anti-aromatic. So this is your aromatic. Sorry, this will be aromatic compound because of 10 pi electrons. So aromatic is 1 and 4. On 3 is anti-aromatic. In case of 5, there are 1 is pi bond and 1 is this electron. So definitely this will be your 4 pi electrons. This will also anti-aromatic. So out of 3 and 5 is anti-aromatic. So our answer is B. Upon reaction with the Grignard reagent followed by protonation, the compound that produces ethanol. So if you take CH3CHO, so in presence of CH3 MgBr, and then followed by your second is your H3O4. So this will convert into your so CH3 CH2, this will convert into CH3, and this is your secondary alcohol is produced over here. But if you take formic acid, no reaction with this. Again, if you take a Grignard, okay, but you can't get ethanol from formic acid also. But in case of formaldehyde, if you take a CH3 MgBr, so in this case HC, okay, so you will get here, so here OH, again you will get CH3, and here hydrogen is added, so you will get here ethanol. So this is answer is correct. In case of this is CHO, so it will convert it to CH2, this one will convert to CH2OH and CH2OH, so we will get ethane diol, so 1,2-diol, by using Grignard and protonation. Grignard and followed by esterified hydrolysis, esteric hydrolysis. So our answer is this formaldehyde is only correct answer. Which of the following is not a redox reaction? The oxidation reduction means redox reaction. Now in this case we can see H2 plus Br2, this is redox reactions. NaCl AgNO3, this is a non-redox reaction. So 47B is the most possible answer. This is the only correct answer. Let us check another C and D. In this case, is this redox? Yes, redox, because iodine and the sulfur undergoing reduction oxidation. Cl2 plus water, definitely this is a redox reaction. So our answer is not a redox, that is non-redox reaction, only B. Remaining A3 are redox. This is redox, this is also redox, and this is also a redox reactions. But this will be a non-redox reaction. Thermal stability of alkaline earth metal carbonates. So we can see this is the alkaline earth metal carbonates. So if you go down the group, what happens? The size of the metallic metals is increasing. The size of the metal is increasing. So what will happen? Ionic character will increase. When size increases, so ionic, you can see ionic characters increases. In that case, ionic character when it is increasing, so in that case your beryllium, this is barium carbonate will having the maximum ionic characters. So there is a force of attraction between the carbonate and barium will be very, very high as compared to the magnesium carbonate. So this is mostly covalent, this is the ionic, so this will be more stable as compared to magnesium carbonate. So order of thermal stability will be first is barium carbonate, then stereoisomers carbonate, and calcium. This is the it is down the group, the stability of the alkaline earth metal will increase because ionic character is also increasing. So if you see carefully, so barium carbonate is most, the first option is given here, so this is only correct answer. When a mixture of diborane plus ammonia is heated, what is the final product? So if you heat like a diborane is B2H6, and if heat with ammonia, so you will get here Bn plus hydrogen. Okay, so final product Bn is not given here. Next, if you give here this ammonia with excess ammonia and plus high temperature, in this case diborane will convert into again here you can see B2H6 and dot 2NH3. So this is the addition product. This is nothing but the addition product. So in this option again this compound is also not given. So if you give excess, ammonia is again excess, but again you are giving what here? Sorry, this is in high temperature. This is our this is not given. This is in low temperature. In high temperature you will get here BnX. Okay, this is your, you can say, boron nitride, so please make it correction here. So this is your low temperature, this is high temperature. Now if you are giving here 450 Kelvin, so you will get the compound in this temperature, high temperature. This will make a cyclic ring like a benzene ring. So you will get here B3, N3 and H6. So these three options are not given, only these options is given. If you see carefully, so this answer is only correct. Among the following metals, the strongest reducing agent is. So these are the metals, very easy questions. So you can use the electrochemical series. So in this chemical series, zinc is the strongest, then followed by iron, and then it is nickel, and then last is copper. So which is strongest reducing agent? Zinc. So this is our answer. The molecule which is not hydrolyzed by water at 25 degrees centigrade is. So in this case, AlCl3, it will react with the water at this temperature. So you will get here AlOH whole thrice plus 3 hydrogen gas released. In case of SiCl4, again it will react with the water, so it will give you SiOH, this is a whole 4, and plus again 4HCl. So this compound is called as orthosilicic acid. Orthosilicic acid. This is acid. And with Bl3 also, it will also react with the water, so it will give you your H3 and B, and then Cl3 is here, and then we will get 3 hydrogen fluoride. Even SF6 also react with water, but we require very high temperature. The temperature is 300 degrees centigrade. So in this temperature, it will convert into H2SO4 and plus HF. So therefore this temperature, and also simultaneously we require high pressure also, high temperature, high pressure. But they are asking which is not hydrolyzed by water at 25 degrees centigrade. So this will hydrolyze, but this will not hydrolyze. So answer is D is correct answer. Among the following compounds, the one which does not produce nitrogen gas on heating. So if you heat this ammonium dichromate, so it will give you nitrogen gas, then followed by Cr2O3. This again, this is color of this gas is green color. This is a colorless gas, and this water is there. And if you take sodium azide, so it will again decompose into nitrogen plus sodium. So again they will give you this nitrogen gas. And if you take ammonium nitrite, so it will give you a nitrogen plus water. So these three are giving you this product. But if you heat this ammonium oxalate, so it will give you urea. That is not urea, this is NH2 whole twice, not NH2CO whole twice. Okay, and then next is your water. So this is produced by this gas. So this is something different product. And which does not produce the nitrogen gas? So answer is this. Remaining three will produce the nitrogen gas. Chlorine has two naturally occurring isotopes, 35 and 37, and atomic mass of Cl is 35.45. This ratio is given. We have to find the natural abundance of 35 and Cl, which is closest to this value. This is a very simple question. So we use the formula of this and this. So average given 35.45, and mass of this chlorine is, let's take 35 is the your mass number, and let's take the abundance is suppose something X for the Cl. Similarly for 37, and let's take the natural abundance for is Y and divide by X plus Y. So if you solve it, this equation on solving, so you will get here 35.45. This is the X, 35.45, and if you multiply by X, and same thing 35.45 multiplied by Y, and this is 35X, 37Y. If you solve it, you will get 0.45X equal to 1.55Y, and ratio of X by Y will be equal to 1.55 by 0.45, and this will give you 3.5:1. So in this case, this is correct answer. The reaction, this is your ethane gas is decomposed into C2H4 and hydrogen, and it is in equilibrium in a closed vessel, and this is temperature. This is an endothermic reaction, you can see here. Now question is, which one of the following actions would shift the equilibrium to the right side? So if you the first is in closed vessel, if you decreasing the volume, so if you decrease the volume, so what will happen? Pressure will increase. So when pressure will increase, the reaction will move backward. Why backward? Because in backward side, number of C2H5 moles is very, very less, so it will go backward. So this answer is not correct. So we have to search right, means forward direction. Decrease decreasing the temperature at which the reaction is performed. Now this is endothermic reaction. So if you decrease the temperature, so again reaction will go backward only, because this reaction is endothermic. Due to endothermic, it will go backward. Now again, if you add the inert gas, but the vessel is closed, means volume is constant. So if you add the pressure also, so there is a equal effect on both the sides. So nothing will happen. In this case, you can say nothing will happen. If the volume is means constant, means it is sealed, so nothing will, I can say, happen. So this again a wrong option. Now increasing in the volume, if you increase the volume, so what will happen? So volume increase, so pressure will definitely it will decrease. So when pressure will decrease, the reaction will goes in that direction where the number of moles is more. So it will goes forward direction, because in forward direction there is 2 moles is there. Because if you increase the pressure, it will goes backward. If you increase the volume, it will go forward direction. Okay, increase the volume, it will go forward direction because pressure is decreases. So our answer is D is correct answer. The enthalpy of a elementary exothermic reaction. So this is exothermic reactions is schematically plotted against the reaction coordinates. So it is plotted. You can see A, B, and C, D diagrams are there. The plots in the presence and absence of catalyst are shown in dashed and solid states. So presence of catalyst is there. So presence of catalyst is which diagram, and absence of catalyst is in a solid line. So this absence of catalyst. So in absence of catalyst, this exothermic reaction, that means heat of product will be definitely, you can see the delta H for product is always less than that of delta H of reactor. So in this case, we can ruled out this A diagram, we can rule out. So it is B is ruled out, so we left A, C, and D in all the cases. Now the top portion, in presence of absence of catalyst, what will happen? The line will be, the solid line will be always higher than that of the dash line. Okay, so dash line means absence of catalyst and presence of catalyst. So this is your presence of catalyst, and this will be your absence of catalyst. And we know very well, like heat of reaction of HA, it is not affecting by the catalyst. So for reactant is again same, and the product is also same. So heat of reaction for HA, it will be always same in despite of using the catalyst. So in that case, this B is again, it is decreasing lesser, and here it is giving increasing is there. You can see the dash, it is increasing. So this is also incorrect, this is also incorrect. So only one option left, that is A is correct answer. Magnesium hydroxide is precipitated when sodium hydroxide is added in the solution of magnesium dipositive. So if the final concentration magnesium dipositive this much value, then concentration OH in the solution is what? So we can write here. So when you are adding Mg2 plus and next is NaOH, so you will get here condition, that is MgOH whole twice, and it will undergo equilibrium. So this will give you Mg2 plus and 2OH minus. So if you take concentration of, this is your S, so it is given here at minus 10, and this will be something 2S, and Ksp again for this is constant. So Ksp for this reaction is how much? It is given 5.6 and 10 to the power minus 12, and this will be 10 power minus 10 into, you can see here, that is your 2S. So this is given here. So 2S means you can take the concentration of OH of whole square, you can take it. So this will become concentration OH will be 5.6 into 10 to the power minus 12 divided by 10 to the power minus 10. This is a whole square there. So if you take a square root on both the sides, so this becomes your concentration OH minus, and this will give you the value of 0.236, which is almost equal to 0.24 value. So if you see in this option, so we have C option is correct. We are getting this value. A constant current is passed for 1 hour through aqueous silver nitrate, aqueous copper sulfate, and molten AlF3 separately. The ratio of the mass of the metals is deposited on the cathode. So we can use the Faraday's second law, that is the weight of silver equal to equivalent weight of, you can say, Ag. Similarly, weight of next is copper, it will be equal to equivalent weight of copper, sorry, Cu. And if you take weight of next is aluminium, so Al will be equal to equivalent weight of aluminium. So there is 3 positive, this is 2 positive, and this is silver is there. So this, if you take in terms of molar mass, this becomes weight of Ag divided by molar mass of Ag. So multiplied by n factor 1. You can see multiplied by n factor 1. And this is weight of copper will be equal to molar mass of copper dipositive. So multiplied by, you can say, divided by 2. And this is weight of aluminium will be 3 plus will be equal to, aluminium will be equal to equivalent weight of aluminium, or you can say molar mass of aluminium divided by 3. So 3 is coming up. So in this case, if you see, weight of Ag is to weight of copper, okay, and then weight of, you can see here, aluminium. This is coming something like molar mass of Ag, and then is to molar mass of copper. That will be divided by, you can see here how much given, is given 2, and if you take the molar mass of next is aluminum, divided by, you can say 3. So if you take the calcium 6, so it will come something like M of Ag, it will come like a 3 of copper, it will come like a molar mass of aluminum. So this becomes your 2M. So ratio is, this is ratio. So in this option only we can see the C option is correct. A reaction has an activation energy of 209 kJ per mole. The rate increases tenfold when the temperature increases from 27 degrees centigrade to X degrees centigrade. So what is the X degrees centigrade? We have to find in degrees centigrade. So we know the equation is log of we can say K2 by K1 is equal to we know the equation, that is delta EA, or you can say divide by 2.303 R, and this is 1 by T1 minus 1 by T2. So we will substitute all this value. So K2 is tenfold, so we can write here log of 10 by 1, and this is given here 209 into 10 power 3. This is in kilojoules, so divided by 3, multiplied by 3, and 2.303 multiplied by 8.314, and temperature is given 1 by, so 27 is again 300 Kelvin, so 273, just add it, you will get 300 Kelvin, and minus 1 by X. Now we have to solve. So log 10 is 1, so we can make cross multiplication here. So this will come this side, so we'll get here this is 1, means multiply this side 2.303, and this becomes your 8.314, and divide by 29. This you can cross this side, 209 into 10 to the power 3, and this is equal to 1 by 300 minus 1 by X. Now we can take X this side, so it becomes your 1 by 300 minus 2.303 into 8.314 divided by 209 into 10 to the power 3, this equation. Now when you solve this equation, on solving this equation, so you will get here, so multiply by, so 209 into 10 to the power 3. So if you solve directly over here also, so if you take divide this into this, so you will get value. So or we will do directly here also, so we can write here 100 300 minus, you multiply it, so it becomes your 19.147, and this will be 209 into 10 to the power 3. So now we can write next is, so you can, this is 3 is there, so we can write here 1 by 300, and this we can take 0.109, we can take it 14 and divide by 209. So we are going to close the value. Now we can write here 209 minus this become 0.019 into 300, and this will be 300 into 209. So if you solve this value, so on solving, so this is, if you multiply it, this is minus, this whole value is 5.742. If you solve it, this is one value. So this whole value is just equal to something, this is 1 by X, this will be equal to 203 something, this is equal to just this will be 203.258, something value will come, and this divide by 209 into 300. Now we can find X. So if you solve this value, so X will be coming 308.474, and this is the whole Kelvin. So if you subtract by how much, minus 273 Kelvin in this whole value, so you will get 35.4 degrees centigrade. This you will get this value. So if you compare from here, so this is only coming 35 degrees centigrade. A mineral consists of a cubic closed packed structure that is formed by the oxide ions, where the half of the octahedral voids are occupied by Al3+. So octahedral means half of octahedral occupied by Al3+, and 1/8 of the tetrahedral voids are occupied by the Mn2+. And we know the very well, so number of octahedral void in this CCB packing will be so octahedral void will be how much? So it will be your, suppose it is N, so this will be tetrahedral void will be your double of 2n. This is tetrahedral void and this is the octahedral void. So double of octahedral void is present in a tetrahedral void. Now in CCP, oxide is how much? Oxide is definitely it is occupying the corner, face, center and centers. There will be 4 atoms. For aluminium, so number of octahedral void is equal to the number of contributing atoms. So contributing atom is 4, so this aluminum will be also something half occupied, means 4 by 2, so it will be 2. And if you take this one manganese, so manganese occupying how much? 1/8 of the tetrahedral wire. So total wire of tetrahedral is 8, so it is occupying the 1 by 8, so it will be 2. So total aluminum is 8 is total wires divided by, so 1 by 8, so total is how much? Total is your 8 by, no, so if total wide is 8, so it will be, so 8 by 8, it will be here 1. So because there are total 8 whites are there, so 1/8 is occupying. So how much manganese is 1? We can say aluminum will be your 2 and oxygen will be 3. This is the crystal chemical formula of the mineral. So if you see closely, only this answer is correct. For a 4p orbital, so number of radial nodes. So radial node is how much? N minus L minus 1. So N is your 4p. So 4p, N is your 4, P is 1 minus 1. So there will be answer 2. And for angular nodes, so this is your L. So L is your, for P is 1. So 2, 1 is the fun answer. So this answer is correct. This is the second part of the chemistry. So of the conducted in the same 5th of number. So let us see solve these questions. So in the following questions, this is the compound and B2S6. So hydrogen. So this is your boro-oxidation is there. Hydroboro-oxidation. So in this case, you can apply the anti-Markov rule. So OH will come this side. So you will get answers. So this is your structures. OH. So this is this one. And if you use anti-Markov rule, so this it will combine. OH will combine on opposite side. So this will be, you will get answers like this one by using, so you will get OH this side and H this side. Now again, if you use a strong oxidizing, so CrO3 is the strong oxidizing agent. So in this present, what will happen? So this will oxidize this carbon. So you will get structures like this one. This is your CHO, and CHO will finally convert into due to a strong oxidizing nature. So it's converted cyclohexanoic acid. So you will say this is a Y structure and this is X structure. So if you compare it, so we'll get this answer correct. In the following reaction, NaBH4 D3O plus is acetic hydrolysis. Now this will give you hydride minus, this will give H plus minus. So in the carbon, it will come like this one. So this is O. So O will take HD and this will take H here. In this case, same thing. So O will take H and this will take D. Now we have to check answer. So in this answer, if you check it carefully, which is correct answer. So ODH is X. So ODH we can see here. So in this case, if you see carefully, so this is HOD. So first X is correct answer. Second is DOH. So DOH. So this is only coming correct answer. So the remaining is not correct. If you see carefully, so this is only our correct answer. Which of the following alkenes can generate optically active compounds upon hydrogenation? So on addition of hydrogen, so what will happen? This one hydrogen will be added on both the sides. So this becomes your chiral carbon is there. So this becomes your chiral carbon, correct? If you hydrogenate this one carbon, so both hydrogen added. So there is a two same groups are present. C2H5. So this is not an chiral. If you hydrogenate this side HH, so again this becomes your chiral carbon. So we can say like this one is there. So this becomes your chiral, this carbon is there. So this is correct. And if you hydrogenate this one, so again after hydrogenation, so what will happen? So both groups are same. So this again it will lose the chirality. Only 1 and 3 is correct answer. So C is the correct answer for this question. When heated in air, brown copper powder turns black. This black powder would turn brown again when heated with what? So let us see this reaction. So copper is reacting with the oxygen. So on reaction with oxygen, it will first form Cu2O. This is your cuprous oxide. This is your cuprous oxide, and this cuprous oxide is red in color. And if you give further oxygen, it becomes your CuO. This is something black in color. Cupric oxide. Now this cupric oxide is when you again heat with, so we have three options. If you are heating with the carbon monoxide, first carbon monoxide suppose, so you will get here copper plus carbon dioxide, so carbon dioxide again oxidized. If you heat with the hydrogen, what will happen? Heat the hydrogen, you will get copper plus H2O. This means this is also possible, this is also possible. Again, if you heat with the ammonia, okay, so you will get here copper plus nitrogen plus your water. This means we have three options. CO is also there, hydrogen also there, ammonia also there. This is correct, incorrect options. So this is something debatable questions because they are asked single alternatives, but we are getting three answers: A, C, and D. The geometry and magnetic property of NiCl4 2 negative. Now here Cl is the weak ligand, so they will not pair the oxygen state of nickel, electrons of nickel. What is the oxygen state of nickel? So from this 4Cl is there, so it will be +2. If we see the configuration of nickel di-positive, this is the configuration of di-positive. So we have, so we can say argon configuration, and then this is your 3D8 because 4S is 0. So if you write this box, so we can write 5 boxes there. So 8 means 1, 2, 3, 4, and 5, 6, 7, 8. So this 2 is unpaired, but this is follow the Hund's rule. Now next hybridization is 4S, and then next is empty is 4P. So we have 4Cl, so 1 Cl will go this side, second will go, third will go, fourth will go. So hybridization will be your sp3. So for sp3, it will be your tetrahedral structure tetrahedral, and we have 2 unpaired electrons, so this will be paramagnetic. So our answer is geometry will be tetrahedral and magnetic property will be your paramagnetic. Among CrEn dipositive, tripositive, tri is there, and 3 positive trans CrEn 2 Cl2 is there, 2 En. This is your again CrEn, ethylene diamine, 2 Cl is there, and ammonia is 4 and Cl2 is 2. So we have to draw the structure to find the optically active complex. So Cr is central atoms. So this is your ethylene diamine. So we can draw structures. So one is like this one is En. So one is En this side, and one is coming from the top. One we can take from down also, like this one. En is there. So one coming from the down, and one we can take this side. So this is En is there, like this one. So this can be D and L form. 2 is there for this structure. So we can take chromium in middle, and for trans, so we can take En this side, and again En this side. Okay, this is there, up Cl. So this is your trans form of this one. This is optically inactive. This is optically active. Now cis Er, En twice, and Cl. So we can take chromium down. So one En we can take like this one up. One is from the upside, and we can take second is your this side is, and one we can take En, one from the up, and one Cl this side, one Cl there. So this is your cis form. So this can be D also or L also. So this is also optically active. Now for this one, cobalt ammonia. So cobalt is central, and we can take ammonia here and NH3 here, and this side is NH3, and here is NH3, and one Cl up, one Cl down. So this is again you can see clearly this is also optically inactive. So our answer will be 3 is optically active, this is optically active. So 1 and 3 is optically active. So this is correct. Actinium-227 has a half-life of 22 years with respect to radioactive decay. The decay follows 2 parallel paths. One is with thorium, one is francium. If the percentage of the 2 daughter nuclides are 2 and 98%, they have given here. So what is the decay constant in per year for actinium to thorium path is closest to? So we have to take one draw with a draw one diagram. This is the actinium. Its mass number is 227. It is getting 2 pathway. One is your thorium, which is 227, and one is your francium, which is 223. So here is half-life is given. That is half-life of this is 22 years, and but we don't know which one your decay constant. Let's say decay constant is your lambda. So this will be lambda 1, lambda 2. Now they are asking for the path of this one thorium. So lambda 1 for thorium will be equal to, so it will equal to lambda of actinium into your, what is percentage? Percentage by 2%, this is 98%. So 2 by 100. Now lambda of actinium is how much? So lambda of actinium is 0.693 divided by 22 years. This half-life is given. We can substitute this value. So 0.693 divided by 22 into 2 by 100. This become 11. If you solve it, on solving you will get 6.3 into 10 to the power minus 4. So this is your per year. So if you see carefully, this answer is correct. Now a system consisting of 1 mole of an ideal gas undergoing reversible process A to B, B to C and C to A. So diagram is given here. Now if the temperature at the starting point A is 300 Kelvin. So this is your 300 Kelvin. What is the work done in the process B to C? B to C they have given 1 liter atmosphere. Already work done for B to C is given here. The heat exchange in the entire process, so entire process we have to calculate. Okay. So we have to find the work done for each process A to B, then B to C is given. This is your 1 is given, and A to C to A we have to find it out. So but 300 Kelvin, so we have to find temperature because in this case volume is changing. If this is 300, so we will use the principal pressure is constant. So V is proportional to T1. So if V1 is this one, temperature 300, and V2 is 1.5. So this will be how much? It will be 450 Kelvin. So we can use V1 by T1 equal to V2 by T2. So 1.5 into 3, that is 300 into, that is 1.5. So you will get 450. Now see in this case, so here you can apply the pressure volume P1 Boyle's law. So if it is 1, it is 2, definitely this becomes your 600 Kelvin. Now we need to find out the work done. So work done is A to B is how much? So A to B, so A to will be, so pressure is given how much? So minus 1, and volume is 1.5 minus 1. So 1.5 minus 1, so it will be how much? So if you solve it, so on getting uses, so you will get here 0.5 minus. So this is your liter atmosphere. Now work done B to C is given, that is given here. B to C is already 1, and work done C to A. So C to A will be how much? So since C to A volume is constant, so total will be 0. So work done from whole process will be, we can take it, it is minus 5, 0.5. This is plus 1, so total will be 0.5. So 1 minus 0.05 will be 0.5. So this answer is correct. A mixture of toluene and benzene boils at 100 degrees centigrade. Assuming ideal behavior, the mole fraction of toluene in the mixture is closest to. Vapor pressure of pure toluene and pure benzene is given 100 degrees centigrade, is this one respectively, and one more giving data. 1 atmosphere is 1.013 bar, so all are in bar, and 100 degrees centigrade it is boiling, so at that time pressure will be 1. So total pressure for this toluene and benzene will be 1. So we'll use the formula of Raoult's law. So total pressure is equal to for both toluene and benzene. So it will be mole fraction of toluene into pure pressure of toluene plus mole fraction of benzene is nothing but the pure pressure of benzene. So we can break this also. The total pressure is 1 atmospheric pressure. We can write here 1.013, and let's take toluene they're asking. So for this is 0.742, and this we can write 1 minus xt, and this becomes your multiplied by 1.8. Now next if you solve it, so on solving this is nothing but 0.742 into xt, and plus this is 1.8. This becomes your 1.8 into xt. So we can subtract over here on subtracting in this case. So you will get here how much value? So 1.8 minus 1.013, so it will be 1.058. So this will be value is coming 1.8, this something value is coming. Okay, now this will be how much? So if you solve it, this one, this into this into this one, so you will get here so how much you will get? 0. You can see just so 1.058. so this will be nothing but it will be xt, and this is equal to 0.787. So if you subtract, you will get this value. So again we can write here xt is equal to 0.787 divided by 1.058. So on solving, this is somewhat coming around 0.744. So our answer is correct. So this is one of the beautiful questions, new pattern of questions, but answer is very simple. The two-dimensional solid pattern formed by two different atoms X and Y, and is shown below. The black and white squares will represent X and Y respectively. The simplest formula for a compound based on the unit cell from the pattern is what? So black is X, okay, and Y is there. So you can count the whole square. There is total 9 is there, and Y is, if you take this is whole column is 9 and this whole column is 9. So 9 into 9, 81 minus 9. So you will get 72 white squares. So put here 72. If you solve it, this is X, Y, 8. So this answer is correct.